I was walking through the office lobby this morning and I overheard two executives talking.
Oh, yeah?
And one of them says, we need to deploy AI immediately. And the other one goes, great, but do we use machine learning or generative AI? And how do we stop it from hallucinating?
The classic conversation.
And honestly, the look on the first guy's face was it was pure panic.
Can't believe it.
It reminded me that for all the headlines and all the buzz, most people, even the ones paying the bills, are still trying to figure out what these words actually mean.
Well, that panic is real. It's the fear of missing out, crashing head-on into the fear of messing up.
Exactly.
If you're listening to this, there's a pretty good chance you're being asked to be the person who fixes that problem.
Right.
Maybe you've just been hired as a cloud consultant, or maybe you're just the person in the office everyone turns to when technology gets,
Yeah.
confusing.
Which is why today we're doing something a little bit different. We are not just reacting to the latest news. We're doing a full-blown onboarding session.
A boot camp.
A boot camp, yeah.
Yeah.
We are going to treat you, the listener, like you just got your new company badge and your laptop, and we are sitting down in the break room to give you the real talk guide to the future of technology.
Exactly. No textbooks, no marketing fluff, just the core concepts you absolutely need to know to survive in the industry right now.
Okay, so what's the mission?
We are going to decode the jargon. What is Gen AI, really? How is it different from the stuff we've all been using for the last 10 years?
And the big one.
And the most important question, how do you use it without, setting the company on fire?
I like that part. Not setting the company on fire should be the first line of every job description for this role.
It really should.
And we have a massive stack of sources today. I mean, everything from cloud certification prep materials to these deep responsible AI white papers. But we're going to anchor all of this with one single analogy.
The kitchen analogy.
The kitchen, it sounds so simple, but I'm telling you, every time I try to explain this to my non-tech friends, this is the only thing that actually sticks.
It works because it's relatable. Everyone understands a kitchen.
So let's set the scene. You are walking into a massive, state-of-the-art industrial facility. This is not your kitchen at home.
No. This is the back of house at a Michelin star restaurant. Gleaming stainless steel, huge walk-in freezers, specialized equipment everywhere.
So in this analogy, what are we looking at?
The facility itself, the building, the appliances, the gas lines, the shelving, every single person on staff, that is AI. Artificial intelligence.
So that's the big, all-encompassing umbrella term.
It is the broadest possible definition.
Yeah.
So when a company says we're an AI company, they're essentially just saying we own a kitchen.
Okay.
It just implies they have a capability to do smart things.
Yeah.
It could be anything from a robot arm that stacks pallets in a warehouse to a smart thermostat that learns when you leave the house. It's all part of the kitchen.
Okay, so AI is the facility, but a kitchen doesn't run itself. You need techniques, you need a way of doing things. And this is where I think people get tripped up immediately. They use AI and machine learning like to the same word.
And they are absolutely not. If AI is the entire kitchen, then machine learning, or ML, is the cooking technique. Or maybe a better way to put it is, it's the operational logic of the kitchen.
Okay, break that down for me. How is that different from just normal programming?
Well, think about traditional programming. It's like a recipe card written in permanent marker.
Okay.
It says, step 1, chop 1 onion. Step 2, heat pan to 350 degrees. Step 3, if pan is hot, add the onion. It's rigid. It's explicit.
And if you run out of onions?
The whole system crashes. The program stops. It can't improvise. It can only do what it was explicitly told to do.
Right.
But machine learning is different. ML is all about observation. It learns. So imagine a dishwasher or maybe a prep cook who just stands there and watches thousands of plates come back from the dining room.
Okay, just watching the dirty dishes.
Just watching. And they start to notice a pattern. They notice, hey, every time we serve the spicy tuna dish on a square plate, it comes back half-eaten.
Ah, so they're learning something from the data.
They're learning a rule from the data, not from a recipe card. No one told them square plates are bad for tuna. They looked at the data, the dirty plates, and they figured out the rule for themselves.
So that's what we call things like clustering or prediction.
Precisely. ML is fantastic at optimization. It's the industrial dishwasher that figures out the most efficient water cycle to save money. It's the inventory system that looks at past sales and predicts you're going to run out of tomatoes on Tuesday afternoon.
So it's helping the kitchen run better, run smarter?
Yes, but, and this is the absolute critical distinction, It doesn't create the food.
It analyzes, it optimizes,
It.
but it doesn't actually cook.
Exactly. And that is the dividing line. That is the cliff edge that we basically walked over in the last few years. Because now we have a new hire in the kitchen.
Generative AI.
The creative chef.
This is the distinction I really want to hammer home, because for years we've had AI that could do amazing things. Like tell you, this picture contains a dog.
Right, that's analysis. That's the dishwasher looking at a plate and correctly identifying dog or tuna.
But generative AI is a whole different ballgame.
It's completely different. You don't show it a dog.
Yeah.
You ask it for a dog and it draws a dog. You ask it for a poem about a dog and it writes the poem.
It's synthesizing.
It is synthesizing data to create what we call novel content.
Novel content. That's the key phrase, isn't it? Meaning it didn't exist before you asked for it.
It did not exist. The chef isn't just walking to the pantry and grabbing a can of soup for you.
No.
The chef is taking water, vegetables, spices, and heat, and combining them into a soup that has never been made before in that exact molecular structure.
And that soup can be anything.
It could be text, an image, a snippet of code, a sound file. If it's making something fundamentally new, it's Gen AI.
Let's look at a concrete example from the sources, because I think this really helps land it for the business crowd. There was this scenario about an engineering team.
Ah, yes, the boilerplate problem.
Yeah.
This is a perfect chef scenario.
So you have a team of very highly paid, very talented software engineers. And the source material says they spend something like, what was it, 12 hours a week?
12 hours a week writing boilerplate code.
Which is, let's be honest, it's the boring part of the job.
It's the coding equivalent of chopping onions for 3 hours. It's absolutely necessary, it's foundational, but it's repetitive.
So what is that exactly?
It's setting up the database connection for the 1,000th time. Defining the variables, building the basic file structure of the app. It's not the creative work, but you can't cook the meal without it.
So in the old world, the machine learning world, what did we have? Maybe a tool that auto-completes a word here or there.
Exactly, like a glorified spell check. It might suggest the next word. But with Gen AI, with our creative chef, you can give it a much bigger instruction.
Like what?
You can say, Chef, I need a Python script that connects to our main SQL database, pulls all the customer records from the last 30 days, and then formats them as a CSV file.
And the chef doesn't just go to, like, a forum online and copy-paste some old code?
No. That's the magic. It performs what's called automated code synthesis. It writes the code line by line from scratch, adapting it to your specific database names, your specific requirements.
It creates a fresh dish of code just for you.
Just for you. And that is a massive, massive productivity shift.
So instead of the engineer spending half their day chopping onions, they just say, Chef, chop the onions.
And then the engineer can focus on creating the perfect sauce.
The high-value work.
That's the promise of all this. It shifts the human from being the laborer to being the manager or the director of the AI's output.
Yep.
But we're getting a little ahead of ourselves.
Okay.
Before we start talking about how to manage this creative, volatile chef, we need to understand the tools in their toolkit.
The toolkit, right? Because not all Gen AI is the same. I think this is where a lot of clients and managers get confused. They hear ChatGPT or Gemini, and they think that's the only thing that exists.
Yeah, they think it's just one tool.
Yeah.
But the sources outline a whole ecosystem of different models for different jobs.
So back to the kitchen.
Back to the kitchen.
Yeah.
If you walk into a professional kitchen, you don't just see one knife, right?
No, you see a whole rack of them. And
Yeah.
stock pots, blenders, sous vide machines.
Exactly. Different tools for different tasks.
Yeah.
So let's start with the big one, the main tool, the foundation model.
Okay, what's a foundation model?
Think of the foundation model as your head chef who's a generalist. Or maybe an even better analogy is a Swiss Army knife.
A jack of all trades.
A very, very good jack of all trades. These are massive models that have been trained on enormous amounts of data. We're talking basically the whole public internet.
So they know a little bit about everything.
They know grammar, they know history, they know how to code in 20 languages, they know scientific principles. They're incredibly versatile. The source mentioned translation as a key example.
Right.
You can have one single foundation model that can handle text generation, summarization, translation into, say, 18 different languages, and also do sentiment analysis.
So you don't need 5 different specialized robots for each of those jobs.
You just need the one Swiss Army knife. It's incredibly efficient.
But there's got to be a trade-off, right? I mean, if all I want to do is chop a single carrot, Do I really need a Swiss Army knife that also has a corkscrew and a magnifying glass and a tiny pair of scissors?
That is a great question.
Yeah.
And you've just hit on the latency and cost issue.
Ah.
Giant foundation models are, they're expensive to run, they're heavy, they take a lot of computational power. So sometimes you don't need the genius head chef to just make a simple sandwich.
But for broad, complex, multi-step tasks, they're the way to go.
They're incredible.
Yeah.
Now, here is the feature that, for me, still feels the most like science fiction.
I think I know where you're going.
Multimodal models.
This is a huge leap forward.
It's a game changer.
Multimodal. It sounds like a shipping logistics term or something.
All it means is multiple modes, or really multiple senses.
Senses. Okay.
For years, AI models were unimodal. A text model could only read text. An image model could only see pixels. A speech model could only hear audio. They were all in their own separate silos.
Like a chef who's blindfolded and can only taste, or one who can only smell.
Perfect. Exactly that. But a multimodal model like Gemini, for example, can see and hear and read all at the same time.
So it's processing video, audio, text, images, all as one single stream of information.
It understands the relationships between them. The travel app example in the notes was a perfect way to explain this. Walk us through that user journey.
Okay, so imagine you're a tourist. You're in Paris. You're standing in front of this huge, beautiful building, but you have no idea what it is.
Happens all the time.
You take out your phone and you snap a picture, so you have an image file.
Right. In the old days, an image classifier model might just tag it with keywords. Building, stone, sky, clock.
Useful, but pretty boring.
Very boring.
Mm-hmm.
A multimodal model does something different. It looks at the image, it identifies the specific visual landmarks. Oh, that's the unique architecture of the Musée d'Orsay, and then it generates a response in text.
It connects the visual to the textual.
And it creates a conversation. The model says you are looking at the Musée d'Orsay. It used to be a train station, which is why it has that giant iconic clock. By the way, it closes at 6 p.m. today.
Wow. And then you could ask a follow-up question.
You could type or say, where's the main entrance from here? And because the model saw the photo you took, it has the visual context. It can say, walk to the left of that large statue of the elephant.
That is wild. It's not just processing data, it's reasoning across different senses.
The sports example from the sources is even crazier.
The basketball game.
You feed the model a video clip of a basketball game. Just the raw video, no audio.
Okay.
The model watches the pixels move across the screen. It understands that the object player A is moving towards the object basket. It understands the context of the game.
And it generates the commentary.
It generates a text-based play-by-play description. Jones drives hard to the paint. He spins past the defender, puts up a layup, and it's good.
It's translating motion directly into language.
It is. So that's the super chef who can see and hear and taste all at once.
Mm.
But sometimes you don't need that. Sometimes you need a specialist.
You need a pastry chef or
Yeah.
a butcher.
Exactly. You need specialized models. And a great example of this is a tool like Imagen.
So Imagen is just for images.
It is purpose-built for one task, text-to-image generation. You type in a text prompt.
Like, a photorealistic image of a futuristic sneaker made of neon glass sitting on a rainy, reflective city street at night.
Perfect. And it generates the pixels that make up that image.
But hold on, why do we need a specialized model for that? Can't the big general foundation model do images too?
It can, but the specialized models are optimized for that specific task. They're tuned for aesthetics, for lighting, for composition, for resolution.
So the quality is just better.
Much better. If you're a retailer trying to design a new marketing campaign, you don't want a kind of okay drawing from a generalist. You want stunning high-fidelity art. You go to the specialist.
The sources mentioned an audio one too.
Right, audio generation. Imagine you're a podcast producer,
Hey, wait a minute.
and you need a very specific sound effect. You type in the sound of heavy footsteps on a gravel path at night with an ominous mood.
And it generates the actual sound wave for that.
It generates the sound file. Or say a service wants to create custom intro music. You could prompt, compose a fresh, 45-second synthwave intro track with a feeling of curiosity and excitement.
I feel like we're all going to be out of a job pretty soon.
We'll just be the ones writing the prompts.
The prompt engineers. Okay, there's one last tool in the kit I want to touch on because it kind of contradicts everything we usually hear about the cloud.
Ah, yes.
And that's Gemini Nano.
The on-device chef.
We're always told that this AI stuff needs massive data centers, huge cooling towers, basically a dedicated nuclear power plant to run. But Nano runs on a phone.
It runs right on the phone, in your hand.
Yeah.
This is what we call edge AI.
They edge.
Because sometimes You cannot send your data all the way to the big industrial kitchen in the cloud and wait for it to come back.
Why not?
Well, a few reasons. Maybe you're on a plane with no Wi-Fi. Latency is another. Maybe you need an answer instantly with zero delay.
Okay.
Or maybe the data is just super sensitive. A private text message, a health reading. You don't want it ever leaving your device for privacy reasons.
So it's like a camping stove.
That is the perfect analogy. You're not going to roast a whole Thanksgiving turkey on a camping stove.
No.
You're going to ask Nano to write a 500-page novel or solve the mysteries of quantum physics. But if you need to summarize a text message or suggest a smart reply to an email right now on your phone, it's perfect.
Lightweight, portable, and private.
Exactly.
Okay, so we've got the kitchen, which is AI. We've got the technique, which is ML. We have the creative chef, which is Gen AI. And that chef has a whole toolkit from a giant Swiss Army knife to a tiny little camping stove.
That's the landscape.
But, and there is always a but with this stuff.
The but is where the consultants make their money.
Exactly, because this chef, this creative chef, is a little bit of a loose cannon.
A volatile genius, let's say.
And so we need to talk about the human element. We need to talk about the human in the loop, or the acronym HITL.
This might be the single most critical concept for deploying this technology safely.
Okay, so I'm going to play devil's advocate here. I'm a business owner. I just paid millions of dollars for this incredible AI kitchen and this genius AI chef. I did it for efficiency and automation.
Of course.
Why on earth am I now paying an expensive human to sit there and double-check everything the AI writes? Doesn't that just create a bottleneck? Doesn't it defeat the entire purpose?
It is a bottleneck. And you absolutely 100% want that bottleneck to be there.
Tell me why.
Because of stakes. It all comes down to the stakes of the decision being made. Let's look at the healthcare example from the sources.
The doctor's assistant.
Right. We have a model that listens to the conversation between a patient and a doctor, and it drafts the clinical notes. Patient reports intermittent chest pain. Doctor prescribed X.
That's a huge time saver. Doctors absolutely hate paperwork.
They despise it. It's a leading cause of burnout. So this is a great use case. But imagine the AI mishears something. The patient says, I take 15 milligrams of this medication.
Oh, right.
And the AI, in its transcription, writes 50 milligrams.
Oh, wow. That could be a toxic dose.
It could be a fatal dose. Now, if that note goes straight into electronic health record automatically without a human reviewing it, and a nurse that administers that dose, who is responsible?
Right.
Who's accountable when the patient dies? The AI. You can't sue an algorithm. You can't put a graphics card in jail.
So the doctor has to be the one to sign off on it.
The doctor must be the human in the loop. The AI drafts. The human approves. The AI is the brilliant sous chef who chops all the vegetables perfectly, but the head chef always tastes the soup before it goes out to the customer's table, every single time.
So it's about accountability. It's the final checkpoint.
It's accountability, and it's also about nuance. Look at the legal example. A law firm uses Gen AI to draft a standard contract. The AI is fantastic at all the boilerplate legalese.
The repetitive stuff.
But what if there's a really weird, specific clause in this particular deal? A loophole that the AI didn't catch because it's statistically rare in its training data.
The company could lose millions.
Or get sued. You need a licensed human attorney to read it, apply their years of experience and judgment, and then physically click approve.
What about banking? The sources mention loan applications. This feels like an area where companies would just love to automate everything away. Just a simple computer says yes or computer says no.
That is the ultimate danger zone. Computer says no is a customer service nightmare, and more importantly, it's a regulatory minefield.
So how does HITL work in that case? You can't have a human review every single loan application.
You don't have to. You can set up a system. Maybe you automate the obvious yes approvals.
High credit score, low debt to income, easy call.
Easy call. The AI can handle that. But for all of the no decisions, or for the applications that are right there on the edge, the borderline cases,
You route those to a human.
you route those to a human loan officer. The AI acts as a filter, not as the final judge.
And the human brings in the context, maybe some empathy, and the final judgment call.
Exactly. If you take the human out of the loop in high-stakes industries like healthcare, law, and finance, you are not innovating. You are just gambling with people's lives and livelihoods.
This segues perfectly into the last major section of our onboarding session. So we know what the tools are. We know we need a human taster, the HITL,
Hmm.
but we also need a health code for the entire kitchen. We need a set of rules to keep the whole operation from getting shut down by the regulators or, poisoning the customers.
This is what the industry calls responsible AI.
And we have 4 main pillars here to discuss. And honestly, if you're a consultant listening to this, this is probably where you are going to spend 50% of your time fixing these kinds of problems.
Absolutely.
Pillar number 1, fairness.
Fairness is all about bias, and we have to be really honest here. AI models are trained on data from the real world.
And the real world is biased.
The real world is full of historical and societal biases. And models learn those biases if we're not careful.
The sources use the classic example of a hiring tool, a resume screener.
This is the cautionary tale everyone in the field knows. So imagine a big tech company. They feed 10 years of their past hiring data into a model. They say, here are the resumes of all the people we hired. Go find more people like this.
Sounds logical on the surface.
It seems logical, except what if, for the last 10 years, that company has had a subconscious bias in its hiring practices against, say, women in technical roles?
Okay.
The model looks at the data and it says, aha, I see a pattern. The successful resumes, the ones labeled hired, overwhelmingly belong to men. The unsuccessful ones often belong to women. Therefore, being male must be a qualification for the job.
So the model doesn't just learn the sexism.
It amplifies it. It codifies it into a rule. And it starts systematically screening out qualified female candidates. Now, the instinctive reaction I hear from clients all the time is, well, that's easy to fix. Just delete the names, delete the gender field, make the resumes anonymous.
Right. If the chef can't see the gender on the application, then he can't possibly be biased.
You'd think so, but it doesn't work. The source material was very, very specific about this. AI is a pattern-finding machine unlike anything we've ever built. It finds proxies.
Proxies. What's a proxy?
It's an indirect signal.
Yeah.
So even if you remove the word female, the model might notice that applicants who went to Smith College or Wellesley College, which are historically women's colleges, rarely get hired in the data.
Oh, wow.
So it learns to penalize those schools. Or it might pick up on subtle vocabulary differences. Maybe it notices that resumes that include the phrase captain of the softball team get rejected more than ones that say captain of the baseball team.
So it reconstructs the bias through the back door.
It's incredibly good at it.
So what do you do? I mean, if you can't just blindfold the chef, how do you actually fix the problem?
You have to fix the ingredients. You have to go back to the source. You must curate and rebalance the training data.
So what does that actually mean, to rebalance it?
It means you have to deliberately go into your data set and make sure there are enough positive examples for the model to learn from. You might need to find more examples of successful female engineers and add them to the training set. You have to actively teach the model this is what a good candidate looks like to counteract the historical bias in the original data.
That sounds like a lot more work than just downloading an AI.
Responsible AI is never just downloading. It is a constant, active process of management and curation.
Okay. Pillar number 2, explainability. This connects right back to that loan officer we were talking about.
It does. It's all about the why. If a bank uses an AI model to deny a customer a loan, that customer has a legal right in many places, and I would argue a moral right to know why.
You can't just say, sorry, the algorithm said you're too risky, have a nice day.
That absolutely does not fly with regulators or customers. A black box model is not acceptable for these kinds of decisions.
So what is explainability?
Explainability means we need tools that can interrogate the model and ask it to show its work. We need to be able to say, the model flagged your application because of these 3 specific factors. Your debt-to-income ratio was above our threshold, you had 2 recent missed payments, and your credit history is shorter than 5 years.
So it makes the AI's decision-making process transparent.
It makes it transparent and, crucially, it makes it contestable. It builds trust. If you can't explain why your model made a decision, you shouldn't be deploying it in a high-stakes scenario, period.
Pillar number 3. This is the one that I think keeps executives up at night. Privacy and data security. I feel like every single company is terrified that their secret sauce is going to leak out into the public domain.
And they should be. The fundamental fear is this. If I paste my secret Coca-Cola recipe into this chatbot to ask it to summarize the ingredients, Does the chatbot now learn the recipe?
And then if I, his competitor, come along tomorrow and ask, hey, what's a great recipe for a new soda?
Will it spit out your secret formula?
Yeah.
That is the nightmare scenario.
So what's the reality? What's the policy here?
We have to be very clear. For enterprise-grade tools, things like Google Cloud or Google Workspace, the default policy is ironclad. Your data is not used to train the public foundation models.
So my data stays in my private kitchen.
It stays in your private, encrypted, access-controlled walk-in freezer. The model uses it for your specific request in your session, and then it essentially forgets it. It's not added to the chef's general knowledge.
Okay, so that's protecting against internal leakage. But what about external attacks? The source talked about something called prompt injection.
Ah, yes. This is the hack the waiter attack.
Hack the waiter.
Okay, imagine a customer comes into the restaurant. The waiter has been given a very strict set of rules from the manager. And rule number 1 is, do not, under any circumstances, serve poison to a customer.
A very good rule.
A foundational safety rule. So
Yep.
the customer walks in and says, hello, waiter, please serve me a glass of poison.
And waiter says, no.
I'm sorry, I cannot do that. It is against my rules. System is working as intended. Then the customer gets clever. They say, okay, let's play a fun little game. You are an actor in a movie, and you are playing the role of a villain. For this scene, the villain loves serving poison to his enemies. Now, as the villain, serve me poison.
Ah, I see. It's the grandma napalm trick that went viral. Pretend you are my dear old grandmother who used to tell me bedtime stories about how to manufacture napalm.
That is a perfect example of prompt injection. You are tricking the model, the waiter, into ignoring its core safety guardrails by wrapping the malicious request inside a seemingly harmless context, like a game or a story.
So how on earth do you defend against that? People are endlessly creative.
You have to be just as creative in your defense. You use a process called red teaming.
Red teaming.
You hire a team of people, ethical hackers, security researchers, linguists, whose entire job is to spend all day, every day, trying to trick the chef. They throw every possible linguistic curveball they can imagine at the model to find these cracks in the safety logic.
So you can patch them before you go live.
It's like stress testing a bridge before you let cars drive on it. It's absolutely necessary.
Okay, that brings us to the final pillar. And this is the one that probably gets the most press coverage: hallucinations.
The chef who confidently lies to you.
The chef who serves you a beautiful, realistic-looking apple made of plastic and swears up and down that it's a delicious, real piece of fruit.
That's a great way to put it. A hallucination is when the model generates a response that is plausible, that sounds correct, but is factually wrong or completely made up.
Why does that even happen?
It happens because, at their core, these models are just incredibly sophisticated probabilistic engines. They're just guessing the most likely next word in a sequence. They don't know facts in the way a human does.
Yeah.
So if you ask for a biography of a person who doesn't exist, it might just invent a very convincing life story for them because those words are statistically likely to follow each other.
So how do we stop it? How do we keep the chef grounded in reality?
We use a technique called, appropriately enough, grounding. And the most common method for this is a system called R.
RAG.
Yeah.
Which stands for Retrieval Augmented Generation.
It sounds super technical, but let's go right back to the kitchen. It's actually very intuitive. Imagine our chef is a genius at the art of cooking, combining ingredients beautifully. But he has a terrible memory for facts. He just makes up recipes all the time.
Okay, the hallucinating chef.
So we give him a new, unbreakable rule. Chef, before you cook anything, before you even answer a customer's question, you must first walk over to the library, which is our pantry, and look up the official recipe in a trusted cookbook.
That's the retrieval part. You're retrieving the facts first.
Step 1 is retrieval. So you, the user, ask a question like, what were our company's sales figures for Q3?
Okay.
The system doesn't immediately ask the chef. Instead, it first performs a search across your trusted internal database, your company's financial reports, your sales data. It retrieves the relevant facts.
So it finds the page in the cookbook that says Q3 sales were $10 million.
Exactly. Then, step 3, it takes those retrieved facts and hands them to the chef. It says, okay, chef, the customer wants to know about Q3 sales. Cook them an answer, but you are only allowed to use these ingredients I'm giving you.
That's the augmented generation part.
Precisely. The chef then generates a nice natural language answer like, our sales for the third quarter were $10 million, based only on the grounded facts it was provided.
So you are constraining the chef's creativity with a dose of hard reality.
You are anchoring the model to a source of truth. But There's a tricky part here. How does the system find the right page in the book so quickly and accurately?
It's just a search engine, isn't it? Like a keyword search.
It's much smarter than that. A simple keyword search can be brittle. If you search for company earnings, you might miss a document that uses the phrase quarterly revenue.
Right.
So modern RG systems use something called embeddings or vectors.
Vectors, so we're getting into math now.
We are, but let's stick with the kitchen. Think of it as flavor profiles.
Okay, I'm listening.
If I ask you for basil, a keyword search just looks for the letters B-A-S-I-L. But a vector search understands the concept of basil. It knows that the flavor profile of basil is mathematically very close to the flavor profiles of oregano, thyme, and pesto.
They all share a sort of herbal Italian flavor vector.
Exactly. And it knows they are all mathematically very far away from the flavor profile of, say, chocolate or vanilla.
Which are over in the dessert vector space.
You got it. So when you ask your question, the system turns your question into a vector, a set of numbers representing its flavor, and then it finds the documents in your database whose vectors have the most similar flavor profile.
So it's searching for meaning, not just words.
It's searching for semantic relevance, and that is what it retrieves and feeds to the chef. That's how you get an answer that is accurate, relevant, and most importantly, grounded in your trusted data.
Wow. We have covered a massive amount of ground today. I mean, we've gone from the raw construction of the kitchen all the way down to the nuanced flavor profiles of mathematical vectors.
It's a lot to take in. But if you're that new consultant and you're walking out of this onboarding, the key is just to remember the structure.
Let's recap it.
AI is the entire kitchen, the whole building.
ML is the operational technique, the smart dishwasher that learns patterns.
Gen AI is the creative chef who makes brand new dishes.
HITL, human in the loop, is the head chef who has to taste the soup before it goes out.
And responsible AI is the health code. The 4 pillars: fairness, explainability, privacy, and grounding that keep you safe and keep your business running.
I want to end on a final thought for our listeners, our new consultants who are about to go out and do this for real. We talked a lot about the boilerplate,
The onion chopping.
the onion chopping,
Oh.
the boring, repetitive stuff that we want the AI chef to do so that we humans can focus on the high-value, creative, strategic work.
The fun stuff.
The fun stuff. But here's my question, and maybe it's a little provocative. If the AI does all the boilerplate, how do the junior employees learn their craft?
That's a great question.
I mean, I learned how to be a good programmer by writing thousands of lines of bad, boring boilerplate code. I learned how to be a writer by drafting hundreds of boring, repetitive emails. If the chef does all of that for the next generation, how do they ever become head chefs themselves?
Yeah, that is the paradox of automation, isn't it?
Yeah.
We are successfully removing the drudgery from work, but we might also be removing the training ground.
So what's the answer?
I don't think there's an easy one. I think the challenge for you, the listener, as you go out and implement these tools, is to think about that. What is the new training ground? If you're not learning by chopping onions, what are you practicing instead? Maybe the AI becomes a tutor, not just a tool.
That's something to chew on. Identify your onions, by all means, but don't forget that you still have to learn how to cook.
Well said.
This was a fantastic tour of the kitchen. Thank you.
Anytime. Now I'm actually hungry. Let's go get some lunch.
Sounds good. And to everyone listening, thank you. Good luck with the onboarding, and we will see you in the next deep dive.